Black holes have always been incredibly hard to study because they suck up all the light and matter that surrounds them. The only way to study them is by studying the things around them. Scientists have accumulated a wealth of information about black holes, and breakthroughs with citizen science have helped them sift through all the information. This was the birth of Radio Galaxy Zoo. Founded on December 17, 2013, the ultimate goal of Radio Galaxy Zoo is to understand the origin, formation, and behavior of black holes, as well as their effects on their surroundings. Scientists are almost certain that a supermassive black hole is at the center of most galaxies, so their study is essential because it helps us understand how the universe formed. It will also help us to understand the nature of physics at the most extreme scales.
The main principle behind Radio Galaxy Zoo is that it compares radio contour images to infrared images and attempts to overlap them to form a complete composition of the structure. These images were all taken from either the FIRST satellite, which stands for First Images of the Radio Sky at 20 centimeters, or the ATLAS array, which stands for Australia Telescope Large Area Survey in Australia. When it comes to images with a mass consensus of at least 75%, volunteer observations are considered just as effective as those of professionals. More than 4,000 volunteers participated in Radio Galaxy Zoo in its first year of operation, with over 30,000 images identified.
Currently, as you can see from the graph, almost that many images are collected on a weekly basis.
The main goal of Radio Galaxy Zoo is to create a massive corpus of classified black holes by means of professional and citizen science. One of the main questions scientists are trying to resolve is how some galaxies formed after the Big Bang. Radio Galaxy Zoo scientists also believe that because black holes are the biggest catalyst for change in our universe, understanding their subtypes and nature might give us a better understanding of galaxy formation. While we still understand the physics and many of the mechanisms of change here in our own solar system, Radio Galaxy Zoo has the potential to help us understand the universe on a grander scale.
Since these telescope images provide pictures of the sky at about 10,000 square degrees, there's simply too much data for scientists to analyze alone. Computers are capable of classifying some specific shapes, but miss the details and reliability of human observation. As a result, there is a need for volunteers to help classify different types of galaxies and black holes by analyzing the radio-infrared emissions. The assistant scientists can then post their results on Radio Galaxy Zoo and talk about them on the forum Radio Talk. Astronomers can then use the citizen science-driven database to help classify black holes. In conclusion, the study of black holes is important to the future of astronomy because it can teach us more about the unknown secrets of the universe. With the knowledge attained from Radio Galaxy Zoo, the mysteries still surrounding the formation of galaxies, possibly even the formation of the universe, and the nature of black holes are ever closer to being solved. This process will not be a quick or an easy one, but with the efforts of citizen scientists and astronomers, the future of Radio Galaxy Zoo looks bright.